Lesson 3.2, exterior angles of triangles. There's what's known as an exterior angle theorem. Exterior meaning some angles on the outside. It states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. What that means is the two opposite interior, so the two angles on the inside of the triangle that are farthest away from this exterior angle, they will add to equal this angle. So 1 and 2 would add to equal angle 3. And I want to talk about why. This angle right here that we have nothing for, I'll just put a star here. This angle, along with angle 3, would make 180 degrees because they're a linear pair, and this angle plus angle 1 and 2 would equal 180 degrees because we learned that all three angles in a triangle would equal 180. So this has to kind of be the constant here in this problem, and then these two would have to equal this because this angle is something different, if that makes sense. But think of these two would make a 180, and it also makes a 180 with these two, so therefore these have to be the same. Okay, so with that being said, what you'll see is a triangle drawn with some kind of exterior line coming off of it. This is the exterior angle. And then these two are the interior. They're inside the triangle. So we can make an equation that says that this angle, which is x degrees, plus 115 degrees, would have to equal 130 degrees. And so you simply just subtract the 115 over, which would be 15 degrees. Now, I will tell you, if you just totally forget this theorem, what you could do to figure it out is if this is a linear pair right here, right, this would be 180. 180 minus 130 would mean this is 50. And then there again, you can see that it's like 180 minus 115 minus 50 would get me that 15. All right, number 2. This is my exterior angle here, the one that's on the outside of the triangle. So this plus this should equal this. So x plus 90 should equal 153. And so all you have to do is subtract 90, which is 63 degrees. So pretty simple if you can remember it. Number 3 just is a word problem. It says in triangle JKL, you've got some kind of expression for the degrees of J, for K, and for L, and it wants you to actually find a specific angle. So your job is to first figure out what is X that would make all of these true, and then plug it back into K's expression. I like to sometimes draw a picture too, and just label any way you want. Let's say JKL, like that. So you've just got angles for each 3. Well, we know that 3 angles of a triangle always add to make 180. So you put 4x minus 10 plus 3x minus 7 plus 4x minus 1 equal to 180 degrees. Combine your like terms. 4 plus 3 is 7, plus 4 would be 11x. Negative 10 minus 7 would be negative 17, minus 1 more would be negative 18. Add 18 over, that would be 198. Divided by 11, I'm not sure what that is. 18. But you can't stop there, that's not a degree. That is just what x has to be, so this would be a 4 times 15 minus 10. This would be a 3 times 15 minus 7, and 4 times 15 minus 1. We only need to plug it in right here. So to find the measure of angle K, you're doing 3 times 15, which is 45, minus 7, which is 38 degrees. Number 4, we've got triangle UVW, and they've got UW is extended through a point W to point X. Let's draw that. Let's say UVW. This line right here, UW, is going to be extended out to point X. The measure of angle UVW would be here. This is 3x plus 16. And then the measure of WUV, W to U to V would be here, is 2x plus 8. And the measure of VWX would be this exterior angle here, is 8x minus 18. And so this is that exterior angle theorem where these two should add to equal this exterior angle. So we can say that 3x plus 16 plus 2x plus 8 would have to equal 8x minus 18. Combine your like terms on one side. I'm going to subtract the 5x over. That'd give me a 3x, add the 18 over. That would be 42. 42 divided by 3 would be 14. But again, they want you to find a specific angle, so you have to plug that in. WUV was right here. So I have to take 2 times 14 plus 8, which would be 28 plus 8 is 36 degrees. And that's it.